This is MCA practice problems 26 through 30. Number 26, please fill in the grid with your answer to the question 26 on page 6 of your answer book. What is the probability that a family with 4 children will have exactly 2 girls and 2 boys? In this case, this is another gridded response, so this is good practice for that scenario. Here's the question. What is the probability a family with 4 children will have exactly 2 girls and 2 boys? So what happens is when you want to look at this, just kind of map it out. The question is, what's the probability they're going to have exactly 2 girls and 2 boys? So this is a girl, and then a boy, and then a boy. The problem is we have different ways of arranging this. This could be girl, boy, boy, girl, or girl, boy, girl, boy, or boy, boy, girl, girl. So in other words, there's a lot of different arrangements where I can get 2 girls and 2 boys. So we have to keep that in mind. First of all, what's the probability of getting a girl? It's 0.5. And the probability of getting 2 of them? 2. What's the probability of getting a boy? It's also 0.5. And the probability of getting 2 of them is also 2. Again, this multiplied out gives us 0.0625. Problem is this arrangement can happen in multiple ways. So what we need to go back and do is say 4 choose 2. This is what we call a binomial probability. It's a binomial setting. In other words, we've got different arrangements, and order doesn't matter. So when you're thinking about your calculator, you got NPR, which is a permutation, and NCR, which is a combination. This is a combination because order doesn't matter. Opposite of what you would think. When you walk up to your locker in school, we call it a combination, but order matters, otherwise you'll never get into your locker. So it shouldn't be called a combination, it actually should be called a permutation because order in fact matters. In this case, order doesn't matter, so we're working with an NCR, which is 4 choose 2. Written out, 4 choose 2 means 4 factorial over 2 factorial times 4 minus 2 factorial. Now you can multiply that out, and the way to do that is to go to your calculator. Just want to show you, here is if you hit the math and then the prob, go over to prob, in other words probability. There's your factorial number 4. Now you can type that all in, or you can use the NCR because order doesn't matter, as long as you remember that. So let's figure out how to do that. First thing you need to do is type in 4, then go to math, prob, order doesn't matter, so I'm going to hit number 3, NCR, and choose 2. And then hit enter. There are 6 different combinations. So this is 6 times the 0.5 squared times 0.5 squared, which was 0.0625, which gives us 0.375. So when I go up to my gridded response, doesn't matter where I put it, I'm going to put it right here. Here's 0.375. And then I've got to bubble in those specific points. There's point, and then the 3 is down below the 3, the 7's down below the 7, and the 5 is down below the 5. It's one way to do to put in your answers for that. Here is some other responses. Notice this one can be moved over, 0.375. This one is the way I have it. You can also have a 0 if you wanted to, not necessary. You can also, if you realize that this was 3/8, write it as a fraction 3/8, and you can write it, even shift it down as 3/8. Either way, the computer is programmed when they go to grade it all the different possible ways that somebody might have typed it in. Let's look at question number 27. It says, use the table below to answer question 27. Rolling a number cube, which is just another word for a die that you use when you're playing games. Cube face 1 through 6, and then the frequency. It says Emma rolls a fair 6-sided number cube, numbered 1 to 6, 18 times as shown in the frequency table. She rolls the number cube 72 more times. What is the range representing the number of times Emma will most likely roll a 3 in her 90 rolls? They're asking for a range, a possibility. And remember, one roll compared to another, the events are what we call independent. One event does not affect the other. So if they rolled a 1, that doesn't mean they can't roll a 1 again. A 1 could pop up. Every time you roll it, it's independent. One will not affect the other. Bottom line is, none of this actually makes a difference. The key here is 3, likely roll a 3 in her 90 rolls. Well, I know the number Q is number 1 to 6, and each one of these faces has a 1 in 6 probability. A 1 in 6, a 1 in 6, a 1 in 6. Each one of them has a 1 in 6 probability. So out of 90 rolls, the probability of her rolling a 3 was a 1 in 6 chance, or I'm looking at 1/6 of 90, and of in math means times, so we're just going to do 1/6 times 90. And when you do that, you're going to get 15 as an answer. So let's go back down here. Which one of these, A, B, C, or D, encompasses or has the range that encompasses 15? My answer is going to be B as in boy. 28. A store has 25 VCRs in stock, but 2 of these are defective. What is the probability that the second person to buy a VCR gets a defective one, given the first customer's was not defective? Round your answer to the nearest thousand. Again, this is one of those problems. You go back, reread it, figure out what their scenario is. And here, one of the key is, given that the first customer was not defective. So the first customer walks in, there's 25 VCRs. First customer buys one, it's not defective. So I'm going to subtract off the 1, which means there are now 24 VCRs because one was purchased, right, by this person. And if none of them were defective, the person that first bought one, it was not defective, that means there are still 2 left. The second person walks in, now there is 24 VCRs, of which 2 are still defective. 2 of the 24 in this scenario are defective, and that's the probability that they're going to pick one that's going to be defective or buy one that's defective, which reduces down to 1/12, which if you do on your calculator is 0.083. 1 divided by 12 is 0.083, which is my answer, D as in dog. Let's look at 29. A survey shows that 55% of the registered voters in Plainville voted on the school budget proposal. Of those who voted, 62% voted to pass the school budget. What is the probability that a registered voter chosen at random voted to pass the school budget? In this scenario, I see a lot of different branches happening and different probabilities. So the best case scenario is to actually go through and draw yourself a tree diagram. We know that 55% voted. That leaves us with 45% that had a no vote. That takes care of this first part. Then it says, of those who voted, so now we're looking at, in this case, this branch, of those that voted, 62% voted to pass the school budget. So let's draw another tree diagram. Voted to pass versus no pass, and 62% voted to pass. So 62% voted to pass, that means 38% voted to not pass. When they ask this type of question, voted, what's the probability that they voted and passed? What you do is you multiply the two branches, 0.5 times 0.62 to get your final answer, and you get an answer of 0.341. Or written out, the probability of vote and pass is the probability of voting times the probability of it passing. 0.55 times 0.62, you get 0.341. So my answer is D as in dog. Best scenario for this one is to draw a tree diagram. Don't be afraid to do that along with Venn diagrams. Some people prefer that. I think a tree diagram works the best in this case. Number 30, the height of a right cylindrical can of peas is greater than the diameter of the base of the can. The can is sliced into 2 equal parts through its bases. Which figure best describes the cross section of the cylinder? This is just a regular can of beans. If we draw it out, it looks something like this, where we know the height is bigger than the diameter. This height is bigger than this diameter, which is what goes straight across. Radius goes from middle to end. We're looking at diameter. This is the radius. Diameter is the whole thing. Says the can is sliced into 2 equal parts through its bases. So you got to think about a saw coming down and cutting it right through the base. And if I cut through the base here, it keeps going down, keeps going down, keeps going down to this end, and cuts through this base. What kind of shape does it leave you with? Well, if you can see it here, some people would say a parallelogram because of the way it looks, but this is a three-dimensional. Pretend like you broke that can open, and it would look something like that, where this is the top and this is the bottom. What kind of shape does that leave you with? It leaves you with a rectangle. So a rectangle, or C, is our best answer for that one. Remember, it says the can is sliced into 2 equal parts through its bases. In other words, it's coming down through the bases and cutting it. That's problems 26 through 30. I hope it helped.